Hi guys, welcome to the second video of my mini-series on Kubernetes. In this video, we're going to be looking at Docker and how it can be used to containerize your applications. Remember that we need Docker because Kubernetes pods, which are the basic units in Kubernetes, are encapsulations over Docker containers. You can use other container engines, but Docker is the one that's most commonly used. So let's dive into what Docker is. Here I've pulled up the Docker website. This tutorial will only scratch the surface of what's possible with Docker. So if you need to find more information, visit the Docker documentation. There are great tutorials here. There's a full reference for all commands. For example, if we want to look at the command line commands, we can do so here, where you'll see a full listing of all the commands and what they do. With that said, let's jump into what Docker is and how it can help us run Kubernetes. So to start, Docker containerizes our Kubernetes applications. It provides a virtualization of the networking and disk drives and allows us to run in a more lightweight environment than a full-blown, say, virtual machine. This makes it more powerful for Kubernetes because it allows us to start up and stop pods more quickly than if we had to boot up a full virtual machine and its operating system. For example, if you have an application that's using Python version 3.5 and you wanted to install it on a bunch of machines, you'd have to manually install Python on each of the machines. With Docker, the dependencies of your application are bundled along with the application code itself, so you don't have to worry about installing dependencies on each machine individually. Instead, all you need to do is make sure that your machine supports Docker, and then any of your Docker containers will be able to run on that machine. When I run Docker on my local computer, what it's doing is creating a local server called the Docker daemon and setting my computer to connect to it. Then when I execute commands on the command line, these commands are sent via REST API to the Docker daemon. If I wanted to, I could also connect to a Docker server running in the cloud or on someone else's computer. This could be useful if I wanted to, say, share containers between a team working on the same project. But for now, all of our commands will be run locally. Before trying the code in this tutorial, we'll need to install Golang and Docker, both of which are free and can be downloaded online. When I run Docker locally, it creates a local registry of all the images built on my computer. This is basically a cache of all of the images or partial images that Docker has built. So for example, if I build an image with a configuration file that's, say, 20 lines long, and I make a change at the 10th line, Docker, when rebuilding that image, will use its cached value for the image that results after the first 9 lines have been executed. This way, we don't have to rebuild all 20 lines of the image. We only have to rebuild from the cached version of the first 9 lines. We'll see how this works when we actually build a Docker image, but for now just know that Docker does its best to cache images and use the cache whenever it's applicable. So let's get into what we can actually do with Docker. To do this, I'm going to be writing a simple Golang server that will simply say hello world on some HTTP URL. So here I'm in a folder that I've titled Go server, and we're just going to make a file called main.go. In this file, we're just going to specify to Go that it's in the main package, and we're going to import a few files that we need for an HTTP server. I'll import format so that we can print things. I'll also import log for logging, and I'll import the net/HTTP package that allows us to perform internet operations with Go. And then I'll write a main function. Before I fill out the main function, I'll also add a simple handler for a URL. We'll call this function say hello, and it'll take as arguments an HTTP response writer and a pointer to an HTTP request. In this function, we'll simply output the string hello world by printing it into the HTTP response writer. So let's make this function say hello. That's it for our simple HTTP handler. Now let's hook up Golang to use that HTTP handler. To do this, I'll simply call http.handlefunc. I'll pass it the URL, which will be, in this case, will be the root, and I'll pass it the name of the function. Then I'm just going to make sure that our HTTP listener is listening by doing a log fatal and saying that there was an error serving application. I'll print out the value of the error, and then for the error, we'll just do http.listen and serve. We'll do this on, let's say, local port 8080. It doesn't matter which exact port you pick. And then I'll put a nil handler, since we don't really need that. As you can see, the handler is typically nil. So this is basically all you need for a simple Go server. We can test it out by running in this folder go build main.go. And as you can see, this has created an executable called main, also in this folder, which I can execute by typing /main. So now you see it's running some process. If I visit localhost 8080 in my browser, we see that it simply says hello, which is what we wanted. So now let's try to Dockerize this application. For now, I'll stop the HTTP server, and then we're going to write a Docker file. To do this, all you need to do is create a file called Dockerfile, and then give it some information on how you want your image to be built. We can think of a Docker file as basically being an installation guide for how our application should be installed on some system. A powerful feature of Docker files is that they can, in a sense, be inherited from other Docker files. In other words, if you want to start in the environment provided by another Docker file, you can do so easily using the from command. So for now, I'm going to type from Golang 1.12. Golang 1.12 is simply an image that contains the Golang already installed on some operating system, Linux, a variant of Linux. We don't really care about the specifics here, but what this will do is ensure that Golang is already installed in my environment. In other words, I don't need to specify installation instructions for Golang. I can assume that it's already installed. Now we're just going to set a working directory. I'll set this to /go/hello docker, which tells us that all of our commands will be relative to this working directory. You can think of this sort of as your home directory on your regular operating system. Now I'll run a copy command. What this does is it basically takes all the files that are in my local folder and installs it in the directory of our image. Since our working directory was /go/hello docker, all of the files in our local folder, which means the main.go and this main executable, will be copied over to our hello docker directory in the image. Again, this is basically an installation guide, and we're starting from scratch. So there's nothing already stored in this directory. We have to manually tell Docker all the files that it needs to copy over to our image. Since I don't really want the main executable to be installed on our image, I'm just going to delete that from this directory. Next, we need to tell Docker that it needs to compile and generate the main executable. When we did this on our local machine, we simply typed go build main.go. So we can do the same thing in the Docker file by using the run command. The run command basically tells Docker that it should execute a shell command inside the native image. So I'm just going to type run go build main.go, and this will generate the image file inside our image. The next thing I want to do is tell Docker that my application will use the internet. Specifically, I want to tell Docker which port this application is going to run on. Since in our Go code, we told our application to listen on port 8080, I'm going to say expose 8080, which will tell Docker that this application uses the port 8080. Finally, I want to tell Docker how it should start my application. This is communicated with the cmd command, and we provided a list of sort of word instructions that tell Docker how to begin the application. In this case, to start the application, all I need to type is .main, because that's what we did to run the application on our local computer. So here I'll just type /main. And again, since we specify the working directory, this command will be run relative to that working directory. Great, so this is all we need for our simple Docker file. Let's see how we can actually run this. If I open up my terminal, again we're in this correct directory, I'm going to first build this Docker file using the docker build command. I can specify a tag or a name for the image using the -t flag. Here I'll call it hello server, and I'll specify the path to the Docker file, which is just dot, because we're operating in this directory. You'll see that I've run these commands previously, so you can see that it's using the cache here in line 2. This means that if I ever want to rebuild this image, for example, you'll see that it's using the cache that it had before. That way, we save time when building images because we don't have to start from scratch. Next, I want to show that this command has been successfully added to the registry, which I can do using docker image list, docker image ls. And here you can see that I have a bunch of images, including hello server, that are added to the registry. Okay, now that we've built our image, I want to run it. So I'm going to use the docker run command and provide it some options. First, I'm going to use the -d flag, which tells Docker to run this image in the background. I'll also use the -p flag, which will tell Docker to publish the ports that we specified in our application. Remember that we specified that port 8080 is used by this application, so this -p flag will need to tell Docker how it should publish port 8080. In this case, I'm going to publish it on port 31555 on my local machine and connect that to port 8080 in the image. So what this says is that port 31555 on my machine should map to port 8080 on the image. Then I'm going to specify the name of the image, hello server. You'll see that this outputted a hash, which is the ID of the container that Docker created. If I now list the commands running using docker ps for Docker processes, I'll see that I have some container ID matching this commit ID, this container ID here, and you can see that hello server with the command /main was started and created 12 seconds ago. Now to test that this is working, I'm going to browse to the port 31555 on my machine, and we should see that this prints hello, as we expect. Note that if I try to connect to port 8080, this will not connect because there's no application running on port 8080 on my machine. It's instead the image running on port 8080 in the image, which is connected to port 31555 on my local machine. If I want to stop the image running, I can use the docker stop command and give it the ID of the container that I want to stop, like so. And you'll see if I now list out the running images, you'll see that the hello server that we started before has gone away. That about wraps up our introduction to Docker. Again, we've only barely touched the surface of what we can do with Docker. In fact, Docker also has its own solution for managing containerized applications and scaling them up and down, much like Kubernetes. If you're interested, you can read up on Docker Swarm and see what else it can do. However, this will be sufficient for most of our goals when we try to push our applications onto Kubernetes using Dockerized images. That's it for this video. In the next video, we'll look at how to create simple Kubernetes objects like pods, deployments, and services, and how these objects will pull our Docker containers from our local registry.